Hello and welcome to finals week. It's great to have you all joining. Great to have a nice audience of people here as well. It's great to see you all. We've got four very exciting presentations lined up for you today from Devarsh, Yash, Rishav and Pranav, who have both been working with us over the summer, and some pretty groundbreaking stuff that we've been doing on Mifos Gazelle that we're looking forward to taking you through. And this will all be stuff that's included in the next release of Mifos Gazelle as well. So not long to wait. You can also get your hands on it and play with it as well. Without any further ado, then I'd like to hand over to Devarsh first of all. Devarsh was working on our project around ARM and looking at what we can do about supporting a wider range of installation techniques. Welcome, Devarsh. Thank you for joining us, and over to you to present.
Thanks. Thank you, David. Hi, everyone. I am Devarsh. So my mentor is Tom Daly, and he had mentored me. He had given me the suggestions. So thank you to my mentors. And let me get started with the project first. So my project was to add the support for ARM architecture in the Mifos Gazelle for the Mifos Gazelle components. So before getting started, let me just take you through that what we have done before the first evaluation, means in the first part of this of what we have achieved. So in Gazelle 12, we had made the progress, like we had added updated the build.gradle file to use JFrog Mifos repository, and then we have updated few dependencies. I am talking about PHEE, the Payment Hub Enterprise Edition, particularly right now. So this Gazelle 12 ticket was focused on particularly PHEE, and this change is made for 1.1.0 Gazelle release. So now moving forward with the main project, which was to add support for all the Gazelle components. So in this project, what we have actually achieved is that my mentor has just suggested me this architecture, and in this architecture, we have created this Python script, and this Python script is being fed by these all repositories, PHEE repositories. And this Python script is responsible to convert this config.yaml file to master config.yaml file. So let us say, for example, we have connector channel. So connector channel have its own config.yaml file in the circle.ci folder. And in that folder, we have this config.yaml file, which is being replaced with the master config.yaml file by this Python script. So now whenever I will do some push to this connector channel, let us say, then this image will be pushed to Docker Hub, which will be supporting AMD and ARM architectures both. So in the under the hood, we have used Docker buildx command. So that's what it was the conclusion. And after that, as I have said that all the images of PHE and all the other components was being pushed to Docker Hub, which were supporting ARM and AMD architectures. So all the three DPGs were running on Ubuntu instance, which was supporting ARM architectures, on OCI instance, which my mentor have provided me, and it was running also on Raspberry Pi. So with some issues which I will talk about in the further slides. After that, we had focused on this Gazelle 32 and ticket, which was particularly about Docker to solve the issue of Docker rate limiting. So we have Mifos Artifactory, JFrog Mifos Artifactory. So we had two images of Mifos, web app and Fineract. So both images was being cached under this JFrog Artifactory to solve the Docker rate limiting issue. So that was all about what we have achieved in the past one term of Google Summer of Code. And in the second term of Google Summer of Code, let me take you through that now. So we have continued our project working on particularly focusing on Raspberry Pi, making all the pods up and running. So few changes were made, like few images were updated about the Bitnami. Bitnami was converted to Bitnami legacy. So this few minute changes were there. And also the major changes was that pods in the Pi was not showing up. Means because of lack of resources or memory leak, this issue was there. So what me and my mentor has tried to do is that we optimize the pods using some AI engines, and we optimize the pods. We have solved the memory leak issues, and I have also focused on optimizing the resources by using uh, hit and trial method. So I have tried each and every methods to optimize all the pods so that they will use the optimistic amount, the efficient amount of resources they need. So neither I will see the OOM error or nor I will be having the pods using too much space, which it does not need. So this is how we have optimized. Now about my documentation, I have documented my complete journey in this Gazelle 12 ticket. So in this Gazelle 12 ticket, every week I was updating that what I have done in the past week, and all over my tenure in this complete Google Summer of Code contract, what I have done, I have documented here in GitHub gist. And if you want that to install Raspberry Pi and to make Mifos Gazelle running, then I have also documented this so that how to install Raspberry Pi here. So you can boot up your Raspberry Pi and test how our project is, Mifos Gazelle components are working on Raspberry Pi. So now let me take you through how the components, Gazelle components are working on our Pi. So we have infra namespace, we have Mifos X namespace, we have payment hub, and we have vNext. So all the pods are up and running, and let me take you through the UI now. So we have this vNext portal. We have this Mifos X portal, Mifos Gazelle portal, where we will be doing the transactions. In one portal, I have logged in as a green bank, and in other portal, I will show you by logging in as a blue bank, and we will see that how the UI is working. So this is how the green bank is being working, and we have this client when we go to institution. And so yeah, let me take you to the home page and then show you. So this is the dashboard, and when we go to institution and then clients, we will see this uh, client of ours which is a part of green bank, and it is doing the transactions, let us say, to particular bank. And here we will see the amounts, and if we want to see the transaction, we can see in here that how much transaction he made, how much balance is there right now is there in his account. And this is all about the green bank. And we also have the blue bank part. So when we go to blue bank, we can see all the transactions made to the blue bank, and basically the banking system we can see in here. So we have the clients of blue banking here. Whenever some transaction is being made to blue bank person, then we can see in here that yeah, this transaction was being made to blue bank person. And when we go to transaction of it, we can see that yeah, $50 were credited to this account. So this is what is all about payment hub, all about Mifos X. And when we talk about the vNext component, we will be able to see that how much money was transferred and to which bank, from which bank to which bank, and this is what vNext is supposed to do. And similarly, we have payment hub enterprise edition portal. So this is all about all the components. Similarly, we have this ZB operate dashboard where we can see the component, the transfers and all. So this is all about the components are running on my Raspberry Pi. So that was the goal, that to run all the components of Gazelle on the Raspberry Pi, which supports ARM architecture, and we have successfully achieved that task, that goal. And now focusing on few more tasks which I will be doing and continue my work at Mifos by with my mentor's suggestion. I have also created simultaneously. I had done this. I have created this script in Mifos Gazelle repository only. What it does is basically that it will uh, trigger when I will commit some push or do some deployment. Then it will deploy all the components, all the Gazelle components in the large Ubuntu Circle CA executor. And if the pods comes up and running, then the test case will be passed. Otherwise, it will fail. So not only that, we will also add the Cucumber test, which will also test for the functions, that the functions are also working or not. And if they are working, then only the Circle CA test will show us that yeah, all the test cases are passing. And so this Circle CA test was suggested by my mentor, and I have been trying to make it. So yeah. this one thing. And my mentor have also suggested me to create an image so that we can test it on Oracle virtual machine. So that's all we are trying to build, and I will be building continue my contribution to Mifos. And at the end, thank you very much, Mifos. Thanks to my mentor who have supported me. I have learned lots of things. I will be also creating one documentation, one blog also, that what I have particularly learned. Like I have learned K9's Circle CI tool and lots of coding side of things also, some technical stuff. So I will be adding that also. So thank you very much everyone for listening me for around 10 minutes. So yeah, I will stop speaking now. Thank you, David. Thank you, everyone.
Thank you very much, Devarsh. No, I mean, it's absolutely great what you've been working on, and it's been great to see. Well, managed to filter some of that into the last release of the Gazelle, and we've got more stuff coming up. It's important the impact of what you're actually doing as well. It may seem we just expanded it to another processor, but by expanding that other node processor, it enables people to be able to access it and deploy it more on their laptops. We've then been able to expand it out to Raspberry Pi devices, which really lowers the cost of being able to do it. So it's great work and really exciting. And I've certainly enjoyed working with you and participating and playing along with my Raspberry Pi and seeing if I can get it working as well. So no, thank you very much for your contributions to Mifos. We look forward to what you're going to continue doing with us in the future.
Thanks.
Next up, we have Yash. Yash has been working on the first of two projects which came out of my brain, and it's really great to actually see what's been created in reality. Lines up to some of the vision I had quite a little while ago for how we take Gazelle in a slightly different direction and enable more people to actually use it. But I don't want to spoil it too much. So over to Yash to present what he's been doing about sort of Mifos Gazelle profile and creator functionality.
Thanks, David. Hi, everyone. Okay, so hi, everyone. I'm Yash Sharma, and I'm excited to be here today to present my Google Summer of Code project with Mifos initiatives. So over the summer, I have been working on developing a comprehensive demo file and selective deployment management tool, which is this Mifos Gazelle demo or profile creator. So I worked on this project under David and Abhinav. Uh, Thanks for helping me out with all the things I've been through between. So so let me start by explaining what this project is all about and why it matters. So the solution I have built consists of two integrated systems that work together seamlessly to provide complete demo lifecycle management. Now you might be wondering why two components. Well, after working in the Mifos ecosystem, I realized there were two fundamental problems that actually needed solving. The first component focuses on selective deployment, which was a critical need because users needed full control over which DPG to deploy and how to configure them. Then instead of the previous all or something approach, I implemented a config.ini based system that gives users better control. The second component handles the demo files lifecycle management. This provides a comprehensive system to create, read, edit, and delete structured JSON demo files. These aren't just random files. They contain step-by-step instructions, metadata, and details that serve as standardized documentation for demonstrating specific features or workflows, which will be used in demo runtime project, which is actually Pranav is working on. So what makes this particularly powerful is that both systems are integrated through a unified Python-based terminal user interface. This means complex operations that used to require switching between multiple tools and manual configurations files are now accessible and streamlined through a single interface. So the TUI approach ensures it works in any environment, local development or remote servers. So now let me dive into one of my most significant technical contributions, like upgrading Mifos Gazelle itself. When I started this project, Mifos Gazelle was essentially uh, less customizable deployment tool. Most configurations were hard coded, which meant users could not customize their deployments based on specific needs. So the first major enhancement I implemented involved extracting all these hard-coded configurations and implementing comprehensive config.ini support. So this wasn't just about like moving settings to a file, but it required like deep understanding of the deployment pipeline of the whole script to identify which parameter should be configurable. That transformation like enabled what I call selective deployment. Users can now choose to deploy only Mifos X for banking scenarios, only Payment Hub for payment processing, or any combination based on their demonstration requirements. So the config.ini approach also supports environment-specific setups, making the tool suitable for various deployment scenarios, from development environments to proof of concept demonstrations. Uh, Now, having a configurable Mifos Gazelle is great, but we needed an intuitive way to manage these configurations. That's where the demo creator TY comes in. The TY provides an intuitive interface for managing all the selective deployment capabilities. Users like access a dedicated configuration screen where they can modify config.ini settings through form-based inputs. No more manually editing configuration files. So that let me now let me highlight some key deployment management features that makes this system good. So first, we have persistent configuration changes. Anything you configure and save will be reused across sessions. You don't lose your carefully crafted deployment settings when you like close the application or something. Second, I implemented live deployment logs displayed in a separate screen that provides real-time feedback during the deployment process. So you can watch as each component starts, see if there are any issues, and track the progress without guessing what's like happening behind the scenes. Then the third, deployment cancellation capabilities, which like allows users to interrupt deployments safely. If you realize you configured something wrong, you can like cancel cleanly without leaving your system in an inconsistent state. So the integration ensures that once users configure their desired DPG deployment settings, they can initiate deployment directly from the TY and monitor progress logs there. Now, let me now shift to the second major component, demo lifecycle management, which like starting with creation. So the demo file management system like provides a comprehensive form-based interface for creating structured JSON demonstration files. When I say structured, I mean these files follow a specific schema that ensures consistency and compatibility across the ecosystem. The creation process starts with users inputting essential metadata, including demo name, description, and involved DPGs. This metadata isn't just for organization, it's used by other systems to list and use it. Then we move to stepwise demo specific details where multiple steps can be created with individual titles, URLs, and detailed descriptions. This is where the real value gets captured. Users can document the exact sequence of actions needed to demonstrate a feature or workflow. The system includes dynamic step management capabilities that I'm particularly like proud of. Users can add new steps using a add step button, remove unnecessary steps with automatic reordering, and edit existing steps. Once demonstration is complete, users can submit their work and immediately see the newly created demo appear in the available demo table, the TY main menu interface. So yeah, the second thing is now that we can create demo files, we need full lifecycle management, and that's where the available demo table comes in. The available demos table serves as the central hub for all demo file operations, like providing complete read, edit, and delete functionality through an intuitive interface. Users can select any demo from the table to open it in read mode, displaying all metadata and step-by-step instructions in a scrollable and easy to navigate format. Then use the edit functionality, which is activated through the edit button that makes all fields editable. Then users can also like modify any aspect of the demo, including metadata, step content, and configuration details, and save operations. Delete functionality includes confirmation dialogues to prevent accidental data loss. So that's all about uh, uh, data file lifecycle. Now, one of the requirements that came up during development was the need to share demo files across teams and environments. That's where cloud integration becomes critical. The system includes sophisticated cloud integration capabilities through JFrog Artifactory support, enabling teams to share and distribute demo files across different environments and organizations. Users provide their Artifactory URL, username, and password credentials through a secure interface that validates connectivity before proceeding with upload operations. But here is what makes this integration intelligent. The upload process includes smart synchronization that first syncs deleted files based on the local metadata.json file to ensure consistency between local and remote repositories. Uh, this actually prevents the common problem of having different versions of files in latest space. Then after synchronization complete, all local files are uploaded to the specified JFrog Artifactory instance with proper organization and metadata. Then the technical architecture is let me give you a glimpse into the technical implementation that makes all this possible. So the technical implementation leverages Python and the textual framework to deliver like a robust terminal interface that handles complex workflows. So I chose textual because it provides the sophistication needed for complex interfaces, like also while maintaining the accessibility and portability of the terminal applications. So yeah, so what does all this mean in practical terms? So this project delivers immediate value by transforming how organizations approach demo management and DPG deployment within the Mifos ecosystems. A user can now create customized deployment, what used to be a complex thing. Organizations can maintain comprehensive libraries of structured demo files and share demonstration resources across teams. This means knowledge isn't trapped in individual members' heads. Uh, then the unified TUI interface eliminates the context switching and provides a streamlined workflow from demo creation to deployment and sharing. Now I'll quickly share and try to give you a small demo the application. Okay, so I hope the terminal is visible. So we have demo creator here. We just need to run the just command I have set up for running the TUI. We need sudo permissions to actually run the deployment through Mifos Gazelle. So once we provide our sudo details, we can do this simple login. Then we can actually now. So this is the main screen. This is the available demo table. We can use this create new demo button to create actually a new demo. Okay. Now here this is the metadata I was talking about for the demo files, and these are the steps. So we can just add the name, thing like login demo. We can provide description. This description is for login. We can provide comma separated DPGs like suppose X. We can have GE. Then we can provide the title, uh, navigate to Mifos X. We can provide the URL here for X form maybe. Then details, click uh, navigate to Mifos X and click the login button. Then we can add steps here. Step 2. For step 2, we can add URL. For next step, we can add details. We can even remove this step if we need to. Then we just need to hit the submit button to save this file. So there is actually, so this is what I was talking about with the validation things. So since we don't actually, so our repository setup without the sudo permission, we are seeing this validation error here. So we can actually work this out. So now let's say we have created a demo. We have a demo here. We can see all the details here of the demos. This is actually the read mode for our demo. If we need to edit any details here, we can just hit this edit button and all the read fields will convert it to editable fields. We can edit this and we can save this for for saving this file. Okay, so we again have this validation because the file is created using the sudo user. Then we can also delete this. This will also show the validation. Yeah. So this is something like validation to actually not provide anyone to access these files, because these files have been created by some other user, we cannot directly delete this or edit or update uh, easily. So that's about the create demo. Then we can use this upload demo files to actually upload all the files to JFrog Artifactory. We just have to provide here our username or the repository URL, and we can provide the repository URL here, password here, and username here. Then we have deploy DPG here. This is actually the config.ini I have been talking about. We can edit this config.ini. Let's say I make this as true, save this config.ini. So the file is saved. Now we just have to hit the deploy button and run the deployment. Since I think I have configured the clean all for the deployment, we are seeing here the logs. This is actually the log screen where we'll be seeing our Mifos Gazelle logs so that we can know what is running here, what is not running here, and what are the issues here. So that's actually all about the demo creator here.
Thank you, Yash. That's great work. And as I say, it's nice to see something out as a conceptual idea come to life over the project. And it's been great working with you on the project over the summer. And we look forward to where it can go in future releases as well. And this will all be bundled up as part of Mifos Gazelle in the next release, even though it has its own repo structure for this particular component. One of the reasons this is important is, as we add more DPGs in, just doing that on a command line and not having that config.ini and not having the ability to be able to edit it would be really tough for users that want to use Mifos Gazelle moving forwards. And that is probably a really good segue into what Rishav will be presenting to us today, because what Rishav has been working on over his internship is actually how we integrate a new DPG into Mifos Gazelle. So Rishav, welcome. It'll be great for you to share with us what you've been working on this summer.
Thank you so much, David, for the lovely introduction. Hi, everyone. My name is Rishav Jain. I've had the great opportunity of interning with Mifos through the Code for GovTech program. So Tom and David were my mentors for this particular project. So my project is integration of Mifos and OpenCRVS. As we all know, Mifos is a DPI as a service which offers payment hub solutions for Mifos X payment hub and other DPGs like vNext. And OpenCRVS, which is the another DPG, external DPG that we are trying to integrate. It is actually an open source platform that helps government register vital events like birth, death. Like this is to improve the civil registration, vital statistics, and promote inclusion. So the objective here was to integrate OpenCRVS with the existing Mifos Gazelle setup to serve the use case of processing a child grant against a birth registered on the OpenCRVS portal. As I mentioned, OpenCRVS registers the vital events, and here we are capturing the birth to process a grant onto the mother's account of the child through our payment hub component. So here the major consideration that we had, this was an input from the official OpenCRVS team also. So there is no direct interface that exists between OpenCRVS and Mifos for payments. And this is not a typical role of civil registration systems, which is actually OpenCRVS. So there is also a social protection layer because this data that OpenCRVS has is quite sensitive because it's the data of individuals, and it has to be only accessible by few individuals, very privileged individuals. So we have to make sure that the security also is in place before going forward with the integration of sending the details of a person over network and getting the payment done from our payment hub component. We have to make sure all these things are taken care of. So initial approach was that OpenCRVS has its setup on Docker Swarm, and as we know that Mifos is on fully on Kubernetes, so we did not know about their migration towards their planning of migration towards Kubernetes. So initially in the first month, we started leveraging their existing repo, their Docker Compose files, Docker images, and I tried to come up with some manifest files for like Kubernetes components, deployment services, attaching persistent volumes, config maps, and secrets. But then there was a major pivot point wherein we connected with one of the technical experts of OpenCRVS. In fact, the DevOps lead of OpenCRVS, who came ahead and made us aware that OpenCRVS itself is working on migration of the Docker Swarm setup into Kubernetes. So this was a very significant discovery, and here it was a decision of both Tom and David, a collective decision that we should make sure that we do not duplicate work, because OpenCRVS is also an environment, ecosystem which is growing consistently, and the changes, it would not be practically possible for us as a different organization, different use case, different system altogether to keep track of the updates of OpenCRVS also. So we decided to leverage their work, help contribute to their like building of Kubernetes setup, and leverage their charts and their setup. So initially, as our plan was to integrate OpenCRVS into the K3S cluster, we in Mifos Gazelle use K3S cluster for the demo purposes and all. So initially there were 3 or 4 non-overlapping components. We also thought of like combining the infra components, but then that was also ruled out because combining infra would again lead to some data inconsistencies. So we dropped that idea. Moving forward, as we progressed, the approach required cloning the official repository, official Helm charts from their repository, making some changes onto that so that the setup resembles and fits well with the current Mifos Gazelle's network architecture. To avoid modifying OpenCRVS core setup, we chose to run it stack independently on K3S, and also to make sure that it matches with Mifos Gazelle's current demo setup. And for this purposes, as I mentioned, we required modifications of the Helm chart and the config. We came up with a script which automatically clones the Helm charts, makes the necessary changes, and gets all the components of Mifos of OpenCRVS up and running as a Kubernetes setup. Okay, so this was the automation script that I was mentioning. Automation script to ensure that OpenCRVS is set up and running, incorporating the necessary modifications in the configuration settings to fit well with the Mifos Gazelle standards. So once the OpenCRVS was up and running, now the major event was of figuring out how the birth registration takes place here. So this particular registration goes through three or four individuals who are at different levels. Initially, there is a social worker in the field who registers the event by the reportee, be it a mother, be it a father, any relative of the child taken the birth, and then it goes to the registration agent who approves the request, local registrar who finally approves, and the certificate is issued thereafter. And talking about the integration part, there is in the latest release of OpenCRVS, OpenCRVS released a separate service to serve interoperability so that other systems apart from out of the ecosystem of OpenCRVS could connect with the events happening within this OpenCRVS ecosystem, and further serve and extend the use cases. So here what we would do is that we would register a callback URL into the OpenCRVS's portal and then get a API call whenever there is a matching birth request. And this API call would be configured at the OpenCRVS's end on the webhook service that they have. So I would like to demonstrate you the birth registration process here. So this is the field worker who registers the process. So to make this very user friendly, I have also so this is the script that I was mentioning. I'll at the end of the demo, I'll run and show you that this gets me all the components running. So these are my components, all the pods are running well. And I have also given some guide wherein to log in, we need to follow these steps. And the reference here has been taken from GitHub page, official page, which gives the details of the login credentials. Initially, the social worker login, which I'll be demonstrating, who registers the event. So a sample event is this. I have made all the necessary entries and kept here. So action date declaration, once all my documents are, all fields are properly configured, ready, and we get to signature here, and then this option is send for review, confirm. Now this comes to the outbox and now it goes to the review. So now next step is going to the registration agent who has to approve the review. So this is the registration agent. If you refresh here, just take a bit time. So I'll have to log in as the registration agent again. Yes. So here, this is box. There seems to be some network issue. Yeah. So hopefully this has been sent. Hopefully, and this way finally the birth is registered on the local system admin. And once the registration happens, the certificate is issued to the concerned mother or the concerned reportee. So here about the webhook integration, we have already created the webhook client, but there has been some like there has to be an approval from the OpenCRVS official team so that this webhook client is configured properly. There has to be an approval from their end for which we are waiting, and hopefully by the end of this week we'll get an input from them, and then this particular integration can be complete. This was it about me. Thank you.
Thank you very much, Rishav. It's absolutely great to see how far you've got, and it's great to actually see. I mean, it's only small, but you could actually see it was like Gazelle.test that interface was working, which absolutely validates that you've been able to install and get it up and running through Mifos Gazelle. So absolutely great work there. Really exciting to have another DPG entering into Mifos Gazelle, and hopefully the start of many more to come. And yeah, once they've resolved the last bit we need, hopefully we'll get some really good end-to-end demos working as well for that. So absolutely great work. Really excited for what you've done, Rishav. Thank you. Next up we have, yeah, thank you very much. Next up we have Pranav. Pranav has been working with us over the summer as well, and it's the second part of that sort of vision I had about how we can sort of make Gazelle help end-to-end demos and make them a bit more real and a bit more tangible for users that may not be just wanting to work at the command line. So I'd like to welcome Pranav to introduce and go through the work here he's been doing this summer.
Hello everyone. So my name is Pranav Deshmukh. I've been contributing to a project named Runtime GUI for demo narration. My interns were David, Tom, and Abhinav. As we know that Mifos has a lot of products like Mifos X, Payment Hub, in VNext, Mifos Gazelle, and a lot more DPGs to come. But the problem every org faces is that how should we show demo of all of the use cases of the products, which is difficult because there can be hundreds of use cases and there can be hundred of end users of or clients who are going to use the products and they want to understand how a particular product works, how a particular use case works, how a data is transferred between the products. So to solve this issue, we were working on this project. So my project is related to Mifos Gazelle, which is an end-to-end deployment tool for all of the products created by Mifos. So what my project focuses, it is a web-based interface for interactive demo exploration. So not just watch the demos or watch a video or read the docs. You can perform the demo yourself on the deployed DPGs and learn how a particular use case or the complete whole of the product works. So why is the runtime GUI pivotal? So it makes you the DPGs understand easier. You can understand all of the use cases there. You can explore all of the things. Then it accelerates adoption. It might cause a smaller, a very slow growth because the clients have to read through all of the docs to understand the use cases. But this project also solves that it accelerates the adoption by performing the demos yourself by just step by step reading the steps and performing it yourself. So it accelerates the adoption. It bridges docs and reality, and it is reusable and scalable. Many DPGs can be added in it. So how does GUI actually work? So what clients will do first that they will they will search for the demos that they want, and then after the demo selection, they will deploy the needed DPGs through Mifos Gazelle. And then when they click on run demo, they can find the two panels, left and right panel. Left panel will have a step-by-step narration of all of the use case of the demo, and they can go through it and perform the demo in the right panel, which contains iframes of all of the DPGs deployed and are being used in the demo. So it has a live interaction. These are not just videos or some static docs. You are performing the demo yourself. You are understanding how it works. So you all retain the information and you understand how the particular use case is working. What tech stack are we using in the GUI? For front end, we are using React.js, TypeScript, Tailwind, Sightseeing, and 3JS for our animations. For backend, we are using Node.js, JFrog Artifactory to store the demo files, and Mifos Gazelle, obviously for the deployments, and Demo Creator CLI for creating the demos that we are going to use here in Runtime GUI. Let me show you how the Runtime GUI looks. So this is the UI. Users can just come here and look at the demos. We have product specific and platform specific demos. Product specific, for example, if you want to understand how all of a product work or a particular use case in a product works, like if I want to understand the use cases inside the Mifos X, I would just click on explore demo and I can search for any of the use case I like and perform the demo myself. Or if I want a demo in which more than one DPGs are being used, all of these demos are present here. You can just click on explore demo and search the demo here. For example, if I want to watch a demo of viewing a payment status, I can also filter the demos through the filter function, and then I can just start on the demo. So these are interactive iframes of the demos, which you can either deploy on your local or on the cloud. And these are step-by-step instructions to perform all of the steps to complete the demo. Like first step is logging into the VNext. So as it is demo to view payment status. You can follow the steps, like log in using the credentials given, and then follow the steps to do all such things. Like if I want to view payment for this particular user that belongs to Blue Bank, and then it takes me to another DPG via Mifos X, which is going to be used here in this use case, and I can log in here using the sample credentials given, and then it gives me all of the steps for this use case. Like you click on institutions and clients, and then click on the client you want to see, and then you can verify. So was this the ID that I was seeing before? Like I can go back to the DPG I was looking and I can see, yes, that particular ID is the same. And I can traverse to the DPGs. I would know that how much the demo of it, how much the particular demo is completed, how much it is remaining. You can even open it in another tab and explore the application. So these are not the static pages. It is a complete application deployed either on a local machine using Mifos Gazelle, or you can deploy on a cloud also and integrate it with the Runtime GUI. And you can explore the complete demos. There can be any number of DPGs here. Like for this demo, particularly we are using 3 DPGs: Phoenix, Mifos, and Payment Hub. So this is how the GUI works. It helps you understand particular use cases and all of the particular DPG that are being used in the use case, and which makes you not just read the docs. You can perform the demo yourself and understand uh, all of the particular use cases in application or in the product created by Mifos. So that was my demo. Thank you all.
Thank you very, very much, Pranav. That's a great way to round off the presentations on Mifos Gazelle. I just think it's really exciting. We actually have some really nice, tangible touch and feel stuff. You know, when we start these internships, you're never quite sure if what you kind of idea at the beginning is going to come out at the end. And it's been a pleasure across all 4 of you this year to really see you grasp challenges. You know, steer them a little bit in your own direction as well, which is love to see your own touches around the edge and get something that's tangible working and the rest of the community is going to really enjoy. So a huge thank you from myself, from Tom, from Abhinav as mentors for all 4 of you. It's great what you've achieved, and we're really proud of you, and you should be really proud of yourselves as well. That's not the end of finals week. There was a clue in the term week. It's just the first presentation set today on Mifos Gazelle. Over the coming days, we have a few more sessions lined up, and we hope that you'll come to join us to see what other interns have been working on as well. Tomorrow, we've got the second session, which will concentrate on the mobile applications. Look what the mobile applications have done with the 7 interns they've had across Mifos Summer of Code, Google Summer of Code, and Code for GovTech. And there's a lot of exciting stuff that I know is already some of it live in new mobile apps we've got out there on the App Store and the Play Store. So please join for that session tomorrow if you can. Coming up on Wednesday, we will take a look at some of the projects focused around Mifos X, our core banking solution. We've had 6 projects this year concentrating on a number of new enhancements for those projects and some really exciting stuff that you will get to see. And then on Thursday, we'll have the last of our finals week sessions, which is focused around AI enablement. AI is a hot topic. You can't go on any call, and I have mentioned AI, so we're definitely covered for this call today. But it's really great that we can actually see what is coming through to actually make it real in the product. So this isn't just AI for the sake of AI. This is AI that will actually enable new features, enable our users to do things they can't do before. We've got some exciting projects from our 5 students there to share with you. So hopefully you will get to join us at one of those sessions over the coming days as well. If you missed anything from today that you want to catch up on, we will have this up on our YouTube channel as soon as possible, hopefully within the next 24 hours, but certainly in the next couple of days. It will be uploaded on our YouTube channel, so you can go back, look, and celebrate. And if you're a student that's watching and interested in doing an internship with Mifos on one of the programs next year, we will have some more details after Christmas of the internship opportunities that we will have available next year. But certainly please do sort of subscribe to our hashtag GSOC channel and our Stack channel, and certainly start, dipping in now into the Mifos projects, getting ideas, and, contributing. That always goes well towards your selection chances for an internship. So thank you for everybody for joining today. Thank you for our presenters. I wish you a good day, and hopefully speak to you again tomorrow. Cheers. Bye.